Dear students, now this lecture is on the sequence, impedance, and network of the transformer. In the previous lecture, we have discussed the we will discuss about the sequence, impedance, network of the transformer. In the previous lecture, we have already discussed the about the sequence impedance of transmission line and a synchronous machine. So as the transformer is a static device, so the positive sequence series impedance of the transformer equal to its leakage impedance, and the leakage impedance does not change with the alteration of phase sequence of balance applied voltage. So the transformer negative sequence impedance is also equal to its leakage reactance. So one thing you have to noted here that positive sequence and negative sequence impedance of the transformer will be equal, and which is equal to the leakage reactance of the transformer. Now discuss about the zero sequence impedance of the transformer. Before considering the zero sequence network of the transformer, some observation are made. First observation: when magnetizing current is neglected, transformer primary would carry only if there is a current flow in the secondary side. So this is the basic theory of the transformer. If we neglect the magnetizing current, thus if in the secondary circuit there is no current or no load, then the current in the primary current will also zero, or it is equal to the magnetizing current of the transformer. Second point, second observation, that zero sequence current can flow in the legs of star connection only if the star point is grounded, which provide the necessary return path for the zero sequence current. If there is an ungrounded star, then the zero sequence current will equal to the zero, because there is no return path for the flow of zero sequence current. And if there is a grounded star, then the zero sequence current may be exist, which is equal to the 3 Ia naught, because it gives the return path to the zero sequence current of the transformer. Third point which is noted here, that no zero sequence current flow in the lines connected to a delta connection. If there is a delta connection and there is a no zero sequence current in the line, zero sequence current can however flow in the legs of delta. The legs of the delta can have the zero sequence current. The zero sequence current may exist here, but in the legs, in the lines connected to the delta connection, there is a no zero sequence current. So now we will discuss the on this on the basic of this observation. We will discuss the zero sequence network of the transformer, and it totally depends on the type of connection. It depends which type of the transformer connection. Either is a star star, star delta, star grounded with delta, or delta delta. So according to the transformer connection, the zero sequence network and zero sequence current will be observed, will be produced. So we will discuss the different type of connection. We take some example here. First connection we will discuss here, the star star transformer bank with any one neutral grounded. We will uh, taken the example of star star connection. This is star, this is star, and secondary star is grounded. Secondary star is grounded. So if we want to make the zero sequence network of this connection, as this is the star connection and this is not grounded, so no zero sequence current flow. Suppose Z naught is the zero sequence impedance of the transformer. As this connection, this primary side has not connected with the grounded, so zero sequence current cannot flow here, so this is disconnected. And as it is grounded star in the secondary, so this winding can be connected to the Z. So this is the per phase equivalent circuit. We can say that a single phase equivalent circuit of the star star transformer zero sequence network of that. Similarly, we can check for the other connection. If there is a star with grounded, there is a star with grounded, Then first we will discuss, we will make the zero sequence winding whose impedance is Z0, and Z0 as is a grounded star, so it is connected to this one. As it is a grounded star in secondary, so this is connected to this one. This is the reference bus. So this is the star star transformer bank with both neutral grounded. If you discuss the star delta transformer bank, primary is star which is grounded and second is delta. Then suppose it is Z node, then primary is star grounded, so it is connected to the line. Line can flow the current. If there is a delta, then no current flow in the line, but it can flow in the legs. So from the line it is disconnected and it is connected to the reference bus. So we have to make sure that whenever the we discuss, we will take the zero sequence current in the consideration for the transformer. We will make rule that for the star with grounded it is connected to the line, star without grounded it is disconnected from the line, and it is if delta, then it is disconnected from the line but it is connected to the reference bus. So there is a again we will discuss star delta transformer. So as a star and with a neutral grounded, basically this is the with neutral grounded, so it is connected to the line, and it is delta. There is some mistake, it is Z naught will connect to the reference bus. Similarly, if delta delta, then Z naught, both are connected, disconnected from the line and connected to the reference bus. So this is the zero sequence network and connection of the transformer. We can take an example for on it now. So suppose this is the network. This is, I think, some misprint here. This is the connected to the line. This is connected to the line. This is generator star with neutral grounded, transformer whose connection is given delta star, line, then star delta, and motor 1 motor 2. So we have to make the circuit for the positive, negative, and zero sequence network for this connection. So first we will, what we have to done, we have to calculate the reactances in our own basis. We have to choose the base value, and according to that we will recalculate the reactance of the transformer, line, motor 1 motor 2 and the other uh, parameters. Okay, now I will not go in for the calculation of the per unit reactance, because this is the part of the per unit which you have already covered. I have to make the circuit diagram for the positive, negative, and zero sequence network. So for the positive sequence network, the EMF is induced EG, then the reactance, positive sequence reactance of the machine, then the reactance of the transformer, then the line reactance, then the transformer T2, then motor 1, motor 2, and this is the induced EMF of the motors, and it is connected to the engine. What will the change will occur in the positive negative sequence network? As we have discussed that no induced EMF will be generated in case of negative sequence network. Other parameter will be same. So this induced EMF will be remove here, and this is the negative sequence network of this circuit. This is the reactance of the motor, so generator, transformer, line, transformer T2, both the motors, and connected to the reference bus. And suppose we will discuss about the zero sequence network for the same network. I will not go for the values. Then the zero sequence network of this connection, this is the another numerical for the same question. So if we discuss about the zero sequence network, then Z0Z is the one thing you have to note down here. No induced EMF will be in case of the zero sequence connection. So EMF has not shown here, and Z0Z is the zero sequence uh, network, zero sequence impedance of the generator. Z0Z plus 3Zn. This is the total zero sequence impedance of the synchronous machine of generator G1. And according to the connection, this is star with grounded. This is point M. Then there is a transformer whose connection is delta star grounded. So Z1, ZT1 is the zero sequence impedance of the transformer T1. As it is the connected is a delta fashion, so it is disconnected from the line and connected to the reference bus from the primary side, and secondary side is connected to the line. Then zero sequence impedance of the line, then zero sequence impedance of the transformer T2, as its primary is connected star with grounded, so it is connected to the line, and it is delta, so it is connected to the reference bus. And third, again there is a generator Z2 whose zero sequence impedance is suppose Z0T, and it is connected in the delta fashion. So if it is connected to delta without neutral grounded, so this is disconnected from the line. This is overall the zero sequence network of the for this circuit. Similar network we can try. So numerical maybe come on this topic, that in the numerical some circuit or uh, some circuit will be given, and question may be like that: draw the positive negative zero sequence network of this circuit. So first of all, you have to calculate the per unit values of the impedances. Then you have to draw the circuit for the positive negative zero sequence network. In case of negative and zero sequence network, no induced EMF will be shown in that circuit. And in case of zero sequence network, according to the type of connection, you have to connect the circuit either from the line or from the reference bus. So these things you have to check and make your numerical. Thank you.